Good morning, this is Mr. Tuttle, and I'm continuing the videos on normal probabilities. We're doing the second problem now. The second normal problem is finding the z-score when you know the probability. Again, you have a choice of three ways to do this. So suppose we want the z-score corresponding to a probability of 0.025 to the left. As before, we'll draw a quick normal curve. The horizontal axis are the z-values. We're going to shade in the area we want. This is an area of about 0.025. Now we're going to go to the normal table in the back of Appendix A-2, and this is an abbreviated version of it. And this time we're going to search in the body of the table for a value of 0.0250. And when we find it, now we're going to move to the left, to the leftmost column, which gives you the z-value to one decimal place, which is negative 1.9, and up to the top row to the second decimal place of the z-value, which here is 0.06. And this tells us that negative 1.96 is the z-score, such that the probability that z is less than negative 1.96 is 0.025. To do this in Excel, we just open Excel and enter the formula equal normsinf 0.025, and it's negative 1.96. Let's do another one. Suppose we want the probability, we want the z-score corresponding to 0.0252. Well, the procedure is the same, but when we go to the table, there is no 0.0252. There's a 0.0256 and there's a 0.0250. So the procedure we're going to use is, if the exact probability does not appear in the table, choose the closest probability. So here 0.0250 is closer to 0.0252 than 0.0256 is, so we're going to use the 0.0250, and again its z-value is negative 1.96. When we go to Excel, we'll put in the proper formula, and Excel will give you the exact value. Although in this case it's pretty close to the same value. Let's do another one. Suppose we want a z-score corresponding to 0.95. Again, we shade in the value. Once again, 0.95 does not appear in the table, but 0.95 is used so often that this is a special case. And for this special case, we're going to take the midpoint between the two closest values, the 9495 and the 9505. 95 is midpoint in between them, and so midpoint between them is the 04 and the 05, and we're going to use 1.645, the midpoint z-value, in this special case because 95 appears so frequently. Finally, suppose we want an area to the right. We want a z-score of 0.025. Well, if 0.025 is to the right, then 1 minus 0.025, or 0.975, must be to the left. So this is the same problem as the one we just did. For 975, we had a z of 1.96, and 1.96 is the same z-value, giving you 0.025 to the right. For this problem, we give this a special notation of z with a subscript of 0.025. Now, how do we do these in StatCrunch? Open StatCrunch. Again, we're going to go to Stat Calculators Normal. We have the same display as before, but this time we're going to use the right box. We're going to put 0.025 in the right box, compute, and it's going to fill in the left box for us. Whoops, I've too many decimal places there. So see, it filled in minus negative 1.96. So you can fill in either the left box or the right box. When you fill in the right box, you're solving for the z-value. When you fill in the left box, you're solving for the probability. And obviously you can do the other problems as well, although